All right, so the second part of section 2.2, still on unit circle trig, except we're going to focus today on three specific angles: a 30, a 45, and 60 degrees. Okay, so we're going to take a look at those three. So these are all angles that are in quadrant 1. They're not on an axis. Does anyone remember what was the name of the 0, 90, 180, 270, those group of angles? Jake?
Like quadrantal.
Right, those are called quadrantal angles because they're all on the axes. These angles are all in between the axes, okay, specifically in quadrant 1. Right. We're going to start by looking at the 45-degree angle. Okay. So the goal, okay, let me just kind of show you what we're going to end up doing. The goal is to be able to answer this question in a minute. Okay. How do we get the 6 trig functions of 45 degrees? Now, we're missing something that would allow us to do this question. What are you missing there? The what? You're missing the coordinate. So we have to figure out what the coordinate is for 45 degrees. Okay, we're going to figure it out, kind of calculate it, but once we know what it is, we never have to calculate it again. Okay, we'll know it, and then we'll just use it. So let's figure out what it is. Okay, so I've started by drawing our unit circle, and I labeled 45 degrees. If that's 0, and that's 90, 45 is right in the middle. Now let's draw the angle. There's your initial side, and there's your terminal side. So basically the whole point of unit circle trig is to figure out where the terminal side hits the edge of the circle. Just want to figure this out. And in a minute, I'll be able to erase the x and the y and actually put in numbers. All right, so to figure this out, in every other angle we're going to work with, we're going to make a certain shape out of that angle in red. Okay. Right now, that's just an angle. It's not really like a poly. It's not like a shape yet. What shape do you think I could make out of that angle in red? Yeah?
A triangle.
Yeah, we're going to make a triangle out of it by drawing a line straight down from the point to the x-axis. So that makes that angle 90. This angle right here is 45. Okay? Sometimes you call that, like if you're doing a word problem, you can think of that as like an angle of elevation. Like if this was like a cannon and it was aimed straight, then it wouldn't go up at all. It would be 0 degrees. If you tilted it up 45 degrees, that's the angle that you tilted it up at. So that's pointing at 45 degrees. Now, what about the other angle at the top? What would that have to be? Check.
45.
How come?
45 is 90. 90 is 180.
Right, all the angles in a triangle have to add to 180. So the angle at the top must also be 45. So I've drawn the same triangle off to the side because I need a little bit more room. In your notes, you might not. It depends how big you write. Now, my goal is to figure out the coordinates. That means starting at the origin, how far to the right do you move? That's the base of the triangle. So that's step 1. How long is the base? And then from there, how far up do you go? That's the height of the triangle, and that's the y value. So if we can figure out the length of the bottom side and the height, those are the two numbers for x and y. We just have to figure them out. Now, what kind of circle is this? We mentioned it yesterday. It's a special kind of circle. It's a unit circle. And what does that mean? The radius is 1. So I know that side is 1. What does that mean about that triangle in black? What do I know about the triangle off to the right? The hypotenuse is 1, yeah. Because the hypotenuse of that triangle is the radius of that circle. They're the same thing. Unfortunately, the 1 is not the coordinate. Okay? I really need to know the length of the bottom and the height. That's the x, the bottom, and the height, y. Okay? So that's what we have to figure out.
So will that mean that the hypotenuse is always 1?
When you draw a triangle inside a unit circle, yes. Yep. All right. I know it's a right triangle, but besides being a right triangle, what other kind of triangle is that? It's isosceles. And that's what's going to help us figure out the other sides, the bottom and the height. What does it mean if a triangle is isosceles? Yeah.
2 of the sides are the same, but 1 is different.
Yeah, 2 of the sides are the same and 1 of them is different. So in this case, I don't know the base and I don't know the height. But if you compare the length of the base and the height, how would they compare to each other?
Should be the same.
They are the same. So whatever you get for x is exactly the same as what you're going to get for y. So the 2 coordinates are the same. So let's just call the bottom x, and we could also call the height x. Doesn't matter what 2 letters you use. Just use the same letter in both spots because they're the same. All right, now we can solve for x. Does anybody remember a formula you can use that involves the sides of a right triangle? Yeah.
A squared plus b squared equals c squared.
What's that called?
The Pythagorean theorem.
The Pythagorean theorem. Yep. So I want to do what Daniel just said, except I don't have an a, b, and c. I have an x and a 1. So could you tell me what you just said using my labels instead?
So x squared plus x squared equals 1 squared.
Yep. And now we're going to solve for x. So we have, if you want to think of it as 1x squared plus 1x squared, what's 1x squared plus another 1x squared? 2x squared. Now 1 squared, I'm just going to put 1. Now I got 2 things left I got to do. I got to get rid of the number in front of the x and the exponent. So yep, divide by 2. And now I almost have x. I've got x squared. But I don't want to know x squared. I want x. So what's my last step?
Square root.
Yep, take the square root. And I'm just going to move it over here because I'm running out of space. So when you take the square root of what's on the left, the exponent's gone. On the right, this is how you do it. Just take the square root of the top and the bottom separate. What does the top come out to? 1. That comes out nice. Now, in the bottom, can you do anything with the square root of 2? Like, does it simplify? No, it doesn't simplify, so it's just kind of stuck there. But can we leave it in the bottom? No. So we fix it just like we had to fix some yesterday. Jenna, do you remember what you multiply the top and bottom by to fix that? Yep, multiply by the square root of 2. If you multiply the top by square root of 2, you get square root of 2. Multiply the bottom by square root of 2, and you get 2. Yep. And there is the length of the 2 sides in green. So the bottom side is square root 2 over 2. That's how far you go from here to there. And the height is also square root 2 over 2. That's how far you go from here up to there. So now when I write it as a coordinate, what would I fill in for x? Yeah?
Maybe square 2/2.
Yep.
Same thing, right?
And then the same thing for y. So there's your coordinate for 45 degrees. We just figured it out using the Pythagorean Theorem. Square root 2/2. Square root 2/2. Anytime you're dealing with an angle that's a multiple of 45, 45, 135, 225, 315. Those are these 4 points I just said. The coordinate always has to do with square root 2/2's. Now, for today, we're not going to do the 135. So you don't have to worry about writing it. But when we do it, all it is a mirror image of the triangle we just drew. So when you mirror image something, do the lengths change? No. They stay the same. But when you write the coordinate for 135, what do you think you have to be careful of? There's a negative, right? There's a negative on the x. So when we do 45s in other quadrants, the coordinates are still root 2/2, root 2/2. It's just sometimes there's a negative with the x, with the y, or with both. That's the only thing that's different. Okay. But for today, all we're going to do is stick with quadrant 1. Okay. Any question on how we got the root 2/2? Right, so now we can answer that question. Find the 6 trig functions of 45 degrees. Okay, so we already mentioned it earlier. We couldn't do this problem because we didn't know the coordinate. Now we do. What's the coordinate for 45 degrees? Mike?
Square root 2/2.
Yep. Comma?
Same thing.
Square root 2/2. So the coordinate is square root 2/2, comma, square root 2/2. If we go back to our notes from yesterday, we already did this problem. This is the exact same problem we did. The only difference is yesterday, I gave you this coordinate. Today, you figured it out. Okay? For those that weren't here, we can go through it just to practice it. So let's start with the sine of 45. Jillian, what's the sine of 45?
Square root 2/2.
And since they're both the same, can you just tell me which one it is?
The right.
The right one, it's the y value. So the sine is root 2/2. Alyssa, how about the cosine? Yep, and which one was that from?
Yeah.
So what's our definition for cosine? It's the
Equals to the
x value. So in this case, if you mix them up, you're okay, but you shouldn't usually mix them up. Right, and now the tangent. 1. Tangent's when you divide y by x. Y and x are the same, so we get 1. Now the trick, so you don't have to remember 3 different formulas, is once you get the 3 on the left, what do you do with each one of them to get the 3 on the right? You flip them. What's the fancy word for that? It's reciprocal. So sine and cosecant are what we call reciprocal functions. So are cosine and secant, so are tangent and cotangent. Right. I know we did it yesterday, but let's just practice flipping this one again. So 2 over root 2. But what do I have to multiply by to fix that? Yep, square root of 2 over square root of 2. That's going to give me 2 root 2 in the top and 2 in the bottom. So what's my final answer? Just the square root of 2. Yep, these cancel out. And now that we've got the cosecant, the secant is pretty quick on this one. What's the secant? Square root of 2. You'd be flipping the same thing again. Okay, so that's done. And how about your cotangent? 1. If you're wondering how do you get 1, just think of 1 as a fraction. 1 over 1. You flip it, it's 1 over 1. Okay. So on the test, that would be 6 separate problems. Even though we just did it as 1. Okay. Any questions on that? Right, so that's the 45-degree angle. Right. What if I asked you for a problem like, say I asked you for the cosine of 405 degrees. What would you do first if you had to do that problem? Subtract 360. 405 minus 360, it's really just a 45-degree angle. We just did that. So if you see cosine 405, it's no different than what we just did. What if I asked for the cosine of negative 315? What would you do there? Yeah, you'd add 360. And once you do that, you would see that it's actually the same problem again. So there's lots of ways I can really keep asking the same thing. Another way you could see something is, what if I had this? Tangent of pi over 4. What might you want to do with that first? Yeah, and once you change it into degrees, it is 45. Which again is one we just did. Okay, so any of that stuff can still come up. Changing radians to degrees or adding or subtracting 360. Okay, so let's look at the 30, 60, 90 triangle. So what we're going to focus on now is how do we get 2 other coordinates. What's the coordinate for 30? What's the coordinate for 60? Let's do the 30 first, and then the 60, once you have the 30, is actually pretty easy. That's 90. That's 0. So 30 is about 1/3 of the way through the quadrant. Right? There's 90 degrees in the quadrant. 30 is 1/3 of that. So here is your answer. Now, to figure out the coordinate, I'm going to do the same thing I did with the 45, 45, 90. What shape am I going to make here?
Triangle.
Yep, let's make a triangle out of it. So there's your 90. That's your 30. And if that angle, like I'm calling it like an angle of elevation and tilt it up at, if that's 30, how do I know the top one is 60? Yeah, right, these two got to add up to 90. The 2 acute angles always have to add up to 90 in a right triangle. Okay, so I drew the same triangle again, just a little bigger over here. Okay, so the goal, we want the coordinate. That means figure out the length of the bottom side. That's the x-coordinate, and then find the height. That's the y-coordinate. Now, is there any side in that triangle that that we already know? Right, the hypotenuse is 1 because it's the radius of the circle. Again, great that we know that, but it doesn't directly give us the coordinate.
Is it always going to be 1?
In a unit circle, yeah. Yep. Now, what kind of triangle is that, besides a right triangle?
Scaling.
It's scaling. What does that mean?
All the words are different.
All the what are different?
All the sides.
Yeah, all the sides are different. So what you don't want to do is this. If you say they're different, well, okay, label them with different letters. But now if you try to do Pythagorean theorem on that, you're going to run into a problem because you have 2 letters in the formula. You can't do that. Okay? If you want to use Pythagorean Theorem, you can only have 1 letter in the formula. Okay? That's why it worked fine here. 1 letter in the formula. Okay? But this is scaling, so you can't label these 2 sides with the same letter. It's not isosceles. So, we got to do something a little different. Okay? And what we have to do is, I'll give you a hint. You have to figure out one of these sides another way. Can't use Pythagorean Theorem yet. You can at the end. But you've got to find another side first. And my hint is that. Does anyone have a thought what I'm going to do with that? Yeah?
Is the height hypotenuse?
It could be, but we don't know that. If you had that memorized from something, you know, that might be something we could rely on, but let's pretend that, I bet a lot of people didn't know that. But it is true.
You put them together to make an isosceles triangle?
All right, we're going to put them together, and you said to make another type of triangle?
Yeah.
All right, how do you want me to put them together? You want me to match up the short sides or the long sides?
Long side.
Okay, let's match up the long sides. So what I have to do that is flip it like that. Okay. Now what?
Well, now you have A and B for the Pythagorean theorem. You have A and B. Yeah.
Not yet.
It's an isosceles now, I'm pretty sure.
It's actually even more than isosceles, it's equilateral. Right? What does equilateral mean? Yeah?
All sides are the same.
Right. Every side in this big triangle is the same, and it means that all the sides are what? They're all 1. So we know this side is 1. I mean, that's not that great. This side is 1. But more importantly, this side is 1. So what does that mean? Why would each one be a half?
Because it's equal.
Right, because they're equal, right? We made a mirror image of that triangle. So those 2 sides are congruent. They have to be the same, and they have to add up to 1. So the only way they can be the same and add up to 1 is if they are both a half. Now we don't need that bottom triangle anymore. We can just look back at the top triangle again. So that copy I made, and you can leave it, but you don't need it anymore. Okay. So now we've got 2 out of 3 sides in the triangle. Let's just label the third side x. And now what can I use? Now I can do the Pythagorean theorem. Now, I already know one of the numbers in the coordinate. Which value do I already know, the x or the y?
Y.
Yeah, the height. The up and down is a half. So if I want, I can fill that in. The only thing I don't know is the horizontal. So let's find it. X squared plus 1/2 squared equals 1 squared. John, if I square a half, that means half of a half, or half times a half, which is how much?
A 4.
A fourth, yeah, it's a quarter. So 1/4, and then 1 squared is just 1. If we bring the 1/4 to the other side, what's 1 minus 1/4? Check. 3/4. And now I almost have x. I just have to do one more thing to get x by itself. Yep, take the square root. And earlier I told you how to do the square root of a fraction. What do you do? Yeah, you do each number. Do the top and do the bottom separate. Square root of 3 over square root of 4. And that will simplify nicely, and we won't have to worry about a root in the bottom. What does that simplify to? Yeah?
Square root of 3 over 2.
Square root of 3 over 2. And that is the length of the bottom side. And that's the x value in your coordinate. Square root 3 over 2. So that is the coordinate for a 30-degree angle. Square root 3 over 2. Now I said once you know the 30, the 60 isn't that hard because, let me draw it. Here's your 60. 2/3 of the way through the quadrant. Okay, so a little bit past half. Look at the triangle that I just drew in black compared to the one that's in red. How do they compare? Yeah, they're the same triangle. The black one is just the red one standing up on the short side, because this angle down here would be 60, and this angle up here would be 30. So the angles just switch places, which means what else is going to switch places? The x and y. So for 60, it's 1/2 root 3 over 2. So all you need to know to do everything with unit circle trig, that's the formulas we learned yesterday for sine, cosine, tangent, and when you flip them, and 3 numbers, you need to know root 3 over 2 and 1/2. Those both have to do with the 30s and 60s. And the other number you need to know is root 2 over 2. And that has to do with 45s. Always. Now, the 45s are easier, I think, because the x and the y are the same, right? The 30 and the 60, you got to kind of remember which one is which. Does the 1/2 come first, or does the root 3 over 2 come first? Well, I'm going to show you an easy way to remember which one is which. As long as you can remember the 2 numbers, you don't really have to remember the order. Okay? I'll show you in the next row. Okay, so let's find the 6 trig functions for pi over 6. Okay. In order to do that, what am I missing? I'm missing the coordinate. To find the coordinate, we could make this problem a little easier if we did what first? Turn it into degrees. So if you multiply by 180 and divide by pi, 180 divided by 6 is how much? 30. So I'm really trying to find the 6 trig functions for 30 degrees. If you memorize the coordinate, great, then you already know what it is. I know that it has a 1/2 and a root 3 over 2. I don't remember which one comes first. So I'm going to draw it like this. Try to draw it somewhat accurate. Try to make the 30 definitely less than half. Okay, it's closer to 0. It's not closer to 90. Make your triangle. Okay. If you draw your triangle correctly, you should be able to tell that there's a short side and that there's a long side. And it should be pretty obvious which side is the short and which side is the long one. Now, there's 2 numbers. There's 1/2 and there's root 3 over 2. What's 1/2 as a decimal? 0.5. Let's compare that to root 3 over 2 as a decimal. 0.866. Roughly. Which one is bigger? Check. Square root of 3 over 2 is bigger. It's always bigger. 0.8 is always bigger than 0.5. The bigger number goes with the bigger side. That's the bigger side. Root 3 over 2. The smaller number goes with the shorter side. So the short side is always a half. The big side is always root 3 over 2. Now, in this problem, the big side is horizontal. It's a $200 pen. The big side is horizontal. What letter is the horizontal? That's my X. The short side is vertical. Vertical is which letter? Y. So this is my X, this is my Y. Without having to memorize which one comes first, I just looked at the picture, and I just know the big side is always root 3 over 2, the short side is always 1/2. That's how I always remember it. So your coordinate, root 3 over 2, comma, 1/2. And if you remember from yesterday, we kind of did problems with these two numbers. If I just go back, we did one with a negative 1/2 root 3 over 2. We're not going to have a negative today. But what do you think this means if there's a negative? It's where?
On the other side.
It's in another quadrant somewhere. So once you throw a negative in front of one of these numbers, it just means you're in either quadrants 2, 3, or 4. This one would be quadrant 2. Any number that's negative, comma, positive, left, up. It's quadrant 2. Okay. So you kind of saw coordinates like that yesterday. We just didn't know what they really meant. Now we know that they mean they're multiples of 30. Okay, so let's go through the 6 trig functions for 30 degrees. Okay, how about Kezia, what would my sine be? Yeah, it's the y value. And that's it. So there's no calculation for sine. How about Lindsay, what would my cosine be? Square root's 3 over 2. There's no calculation for that one either. Okay, and Morgan, what would my tangent?
It'd be 1/2 over square root of 3 over 2.
Right. So what I do in my head is I just pretend like there's a division line right there, and I'm dividing these two numbers. Y divided by x. That's what Morgan just said. When you divide those, what cancels out? The 2's. I'm not going to erase the 2's because they're part of another answer, but in my mind, I'm just going to pretend like they're gone and write 1 divided by square root of 3. So 1 divided by square root of 3. All right, and what should I do there?
Multiply by square root of 3 on both.
Multiply by square root of 3 on the top and on the bottom. I want to circle, or I'm just going to put an arrow pointing to what we had originally, because I want you to keep that number in mind, 1 divided by the square root of 3. And now we're fixing it. So there's my answer. Square root 3 over 3. Yeah.
Tonight's homework worksheet.
Yes.
Should I grab that?
Yes. Yep, right on the front. So once you get the 3 on the left, all you have to do is what to get the 3 on the right? Yep.
Do the reciprocal.
Yep, let's do the reciprocal. So first one, that one's easy. So positive 2. How about the secant? Anyone think they can tell me what you get when you flip it and fix it so the root's not in the bottom? Yeah.
Is it 2 square roots of 3 over 3?
Yep. 2 square roots of 3 over 3. Now, with the cotangent, you could be clever and save yourself a little time. You can flip what I'm pointing to in red, and that will work. Or you can flip what I'm pointing to in black. They're the same thing. Which one do you think would be better to flip? Yep, Jake.
1 over square root of 3.
Yeah. Why is that one going to save us a little time?
You will end up with a square root on the bottom.
Right. If you flip the one that I'm pointing to in red, can you grade that before? Yeah. You're going to end up with a square root in the bottom. If you flip the one in black, the square root goes to the top, and you're done. So again, on the test, that would be 6 separate problems. Any questions on how we got this 6 trig functions for 30 degrees? Okay, so let's finish up with the 6 trig functions for 60 degrees. Okay, so take a couple minutes and see if you can figure out what those are. If you get a lot of numbers that look similar to what we just went through, then you're probably on the right track because the 30 and the 60 30 and 60 coordinates are pretty much the same. I'm not going to tell you what's different because we already did it, but we'll do it in a second. Okay, so give that a shot. All right. So they want us to find all 6 trig functions for 60 degrees. Okay. We mention it pretty much every time we have a problem like this. What am I missing that I need to find first? The what? Yep, got to get the coordinate. Can't do anything without that. So what is the coordinate for 60 degrees?
It's 1/2 3 square of 3.
The square root of 3 over 2.
The square root of 3 over 2. Yeah. So 1/2 is the short side. That's going to be on the bottom. 3 over 2 is the tall side. That's going to be the height. Okay. Now let's just go through and see what we get. So, Lillian, what's my sign?
3 over 2.
Yep. 3 over 2. Cosine, I'll do that one. That's a half. Those are the only 2 you don't have to do any real calculations for. Maddie, how about the tangent?
I did mine wrong. Excellent.
Okay, what's the formula for tangent?
Y over X.
Y over X. So we're just going to take and divide these 2. If I divide these, what's going to cancel?
The 2.
The 2's are gone, and I'm left with square root of 3 divided by 1, which is just the square root of 3.
I did the same thing. I was on the other side.
Carissa, what about my cosecant?
2 square root of 3 over 3.
Okay, so what she said is perfect. She flipped it, fixed the root in the bottom, gave me the final answer. 2 root 3 over 3. My secant, how about Nicoletta? 2? Yep, when you flip that one, that's nice because there's no root. And the cotangent is going to be
3 square root of 3.
what did you get?
I got the 3. Square root of 3 over 3.
3 square root of 3 over 3.
It would be square root of 3 over 3.
Yeah, it would be square root 3 over 3.
That's what I said.
Can you figure that out?
Yep, so when you take the tangent and you flip it, there's nothing there to flip right now,
Yeah.
so I'm just going to put a 1. That's what I get when I flip it, and then when I fix it, multiply by square root of 3 over square root of 3, and that's how you get the square root of 3 over the square root of 9.
Okay, how did you get the CSC?
The top one?
Yeah.
So that one's pretty much the same thing, except instead of having the square root of 3 over 1, it's the square root of 3 over 2. So basically just change the 1 to a 2. Yep. So you get 2 over the square root of 3, and then you multiply top and bottom by square root of 3. Hey, now look at the answers we got on the left. Certain ones switch places. Did anybody see two trig functions that this one and this one switched places from the 30 to the 60?
The
Yep.
sine and the cosine switch.
Yep. The sine and the cosine switched from the 30 to the 60. What else switched?
The tangent and the cosine.
The tangent and the cotangent. Those switched. And which other two switched places, Shay?
The cosecant.
Cosecant and the secant. So the groupings that switched is a little bit different than the reciprocal. Reciprocal is just when you look in the same row. You flip what's on the left to get what's on the right. Let's kind of pronounce what's in each box. Sine, cosine, tangent, cotangent, secant, cosecant. So the pair, when you pair them up like that, those are called cofunctions. A cofunction is just when you put the word co in front of a trig function and then say it. So the cofunction for tangent, cotangent. The cofunction for secant, cosecant. And the cofunction for sine, cosine. Okay. So if I wanted to kind of write that, the blue box, red box, and green box, these are cofunctions. And we'll talk more about cofunctions and why that happened next week. So any questions on that? All right. So the homework tonight, there's 10 questions on a worksheet. And there's 5 other questions that I didn't get to put on the worksheet that you need to copy those down, or you can just get them from the video, but you have a little under 20 minutes, so you've got plenty of time to copy them right now. Okay, so I'll give you guys the worksheet. Please use the time to try to get started. If you have any questions, let me know. Tomorrow we will finish everything for the week. That's my plan. And then Thursday will be a review day, and I'll also be after school if you need to make anything up. Or if you want to make something up in Thursday, you can do it during class, because we're not doing anything